The broadcast is now starting. All attendees are in listen-only mode.
I'd like to welcome everybody to today's webinar given by Neutrik on fiber optic theory, products, and applications. I'm Kim Robbins, Senior Marketing Manager at BTX, and I'll be your host throughout this session. Joining me today is Fred Morgenstern, Neutrik USA's Product Manager. Fred is the point person for all fiber optic technology in the U.S. from Neutrik. He's an AV veteran with live event, studio recording, and OEM experience, and is an outstanding person to lead us through today's CTS accredited course. Thank you, Fred, for joining me today. This is a sweeping course on fiber optics for the AV professional and covers a great deal of ground in 2 hours. You'll learn the pros and cons of using fiber optic versus alternative technologies. You'll get a better understanding of the basics of fiber optics, and you'll also hear about cool AV applications using fiber. We love questions, so please feel free to ask as many as you'd like using the questions area on the toolbar. When you work with BTX, you work with a team of people whose mission it is to take you beyond distribution and be your partner of choice. In addition to supplying many thousands of the finest interface, integration, and system products, we also engineer our own unique and patented solutions. We have deep technical expertise on all of the solutions we provide, and our application engineers, inside and outside sales teams, are readily available to help you specify, purchase, then support your product requirements. Our full product line card offers thousands of products to make implementation of your projects run smoothly. Among the many key integration building blocks that we provide are custom cable assemblies, custom plates and panels, video extenders, signal distribution, cable management, and of course, fiber. And on that note, I'd like to send us to the main attraction, which is Fred's presentation. As a reminder, feel free to ask any questions, and we will certainly take them as we are moving along throughout Fred's presentation. So Fred, I think you should now have a little box that says show your screen. Here we go.
Right. And do people see it?
I see it.
Okay, very good. Kim, thank you very much. And, for everybody, thank you very much for attending. I've gone to a lot of trade shows. I meet a lot of people. Maybe we can use the chat window here just real quickly. If anybody has met me, if you want to say that, you've met me in the chat window, just so I know. All right, looks like nobody's met me. All right, good to know. And then the next question, which is actually fairly important, is if in the chat window, if you can indicate, are you sort of a new to fiber? Have you been doing it a while, or are you an expert? It would be nice to see these responses from the attendees, and this can help me sort of gauge my presentation and try to speak to the right level.
Okay. I am. And people are answering in the questions area. So believe it or not, people have met you, Fred.
Oh, okay, very good, very good.
And,
or sorry, I don't know.
we have a wide range of people with experience. Some have been doing it a while. We've got a handful, I'm going to say 6 to 1, 10 to 1 are kind of new, and then we've got a bunch that are right in the middle. So okay. You've got a wide variety of people to speak to.
All right, good. Well, I cannot see the questions that are coming in. I don't know why this is the case, and I can't see the chat. But Kim will interrupt me often so that we can stop and we can, talk through any of these particular issues that might come up. Don't let me just kind of ramble on. I think it's important that we have a nice, real understanding, really learn what's going on here. So having said all that, let me just try to get this doc out of the way here for myself. Let's begin. So this presentation is on fiber optic theory, products, and applications, and it's really designed for AV. Also, use your questions or your chat and let Kim know if you're a CTS person, if you're looking for a CTS credit today. That'll be important. If you're looking for a CTS credit, like all these presentations are supposed to work, we'll actually have a quiz at the end of the presentation, which you will have to take, which will be fun. But if you're not looking for that CTS credit, then you can just sit back and play. So let's take a look at what we'll be talking about today. By the way, I tried to open up my PowerPoint in full screen and I crashed my PowerPoint, so I'm going to not use the slideshow version here. We'll just use the standard presentation version. So here's what we'll talk about: the pros and cons of fiber optics. Why would you choose fiber optics as opposed to choosing a copper solution, or in some cases a wireless solution? Then the technical basics of fiber optics, and this is always worth going over, the light spectrum and multiplexing, these sorts of things. We'll talk a lot about Neutrik's opticalCON. This is one solution for rugged fiber. There are other solutions as well, but of course this is the self-serving part of the presentation. But as we talk through this, we'll also be talking about certain things that you need to think about as you're actually implementing a fiber solution. And then lastly, we'll talk about some of these AV applications. Where is fiber used? Where do we see more use? Where is it applicable? Where is fiber really not so applicable? Because the fiber is so expensive, we always want to make sure that we're implementing it where we need to implement it, and that we're not over-implementing it or under-implementing. Finding the right uses for fiber. So that's the agenda. And are there any questions? Otherwise, we will begin.
I think we can start moving forward.
All right, so let's talk about some of these pros and cons of fiber optics. The most important pro for fiber optic is that you've got this dramatically increased data density, and some of these statistics are really mind-blowing to me. If you have one 12-fiber cable, so it's a cable that's got 12 fibers in it, you can carry as much data as 160 individual Cat6 cables. So, that's kind of an extreme case, but you can see that the more that you can multiplex onto a system, or the more data you can carry on one cable, it means you've got easier system integration because you've got fewer connections. You're saving a lot of weight. And so take a look at this statistic: 40 pounds for fiber versus 1,000 pounds for the equivalent twisted pair cabling. So the weight savings alone have been a really big issue for the mobile production trucks that are going from city to city to city for sporting events, because transportation costs and gasoline costs are significant for them. It's also been really significant in the audio snake market, and we've seen a really pretty precipitous decline in these big multi-core analog audio snakes that go from the stage up to the front of house in favor of fiber, because it's just so much lighter and so much easier to handle. And again, another part of this pro of dramatically increased data density is the overall cost savings, because if you're running that much data and you don't need to run all that copper cabling, well, then you can save money with fiber. And Kim, just interrupt me when a question comes in.
I will do that. Thank you.
Okay, sounds good. Sounds good. All right, so let's talk about the next pro. The next pro is longer data runs, and this is also really significant. Any twisted pair solution is really technically limited to a 100-meter run for an install and a 70-meter run on location. And then there are people who run, HDMI, or they run some sort of copper signals for high-def video. And when I talk about high-def, I'm only talking about 1080. We're not yet talking about 4K, which will be even more of an exaggerated difference. But for high-def video, a lot of people don't want to run this over 15 meters. And I do have to say, I'm the point of contact for Neutrik technical support questions in the U.S. And I do get these people who call in and say, hey, I'm having some problems with my system. And after a lot of questions, it turns out that they're running their copper cabling, their Cat5 or their Cat6 or their HDMI, just a little bit longer than they really should and than they technically should. And they get in these edge cases where they start to have these problems where, there's distortions, there's dropouts, there's dead pixel, what appears to be dead pixel areas, and other kinds of problems. So, when you're working with the copper world and you're working with these high bandwidth applications, Cat applications, you've got this 100-meter limitation. By contrast, multimode fiber can run over a mile, and single mode fiber can run over 10 miles. And so once you move to fiber, you typically just blast away all of your concerns about your cabling lengths. And this is nice too if you're working on a campus application, or if you're thinking, well, I know I'm going to have to get video or data somehow from point A to point B. I don't really know how long it's going to be, in the worst case. Well, once you move to fiber generally, you can just completely ignore all those issues, which is nice. Okay. Pro number 3, complete electrical immunity. So, fiber is not conductive. That means you don't have to worry about any kind of cell phone interference, RFI. You don't worry about lightning strikes. You don't worry about any of that stuff. You are completely taken care of once you move to fiber, because now you're transporting data over light, not over copper. Once you do the digitization, that digital signal is not going to degrade as it goes from source to destination at all, regardless of any kind of, traditional interference. And this is a beautiful thing for people. So when you want the highest possible fidelity, and that's what I talk about here in the second paragraph, you digitize your analog signal as close to that source as you can, as close to the preamp or as close to the source as you can get. Transmit that signal over fiber as long as you can, and keep your copper run short. And it will improve your signal, will eliminate all these worries about cell phones and other sources of interference. The next pro about fiber is it is a green solution, and this is one of my favorite slides, not just because of the frog, but check out this statistic. You can make a fiber optic cable from 60 pounds of sand that will transmit as much data as traditional cabling requiring 1,000 tons, in other words, 2 million pounds of copper. Now, I put this slide in here a couple years ago when all of these raw material costs were going through the roof. Gold was sky high, and copper and silver and everything else was following along with gold. Now, since then the market has changed, and copper is not under those kind of price pressures that it was. But there's no doubt that over time, fiber will continue to be made from sand, and the use of copper is we're not going to find amazing new amounts of copper which are going to make it cheaper. So you combine the weight savings with the materials, and it's another real pro for fiber. So hopefully you can see that fiber's got a lot of advantages. Again, most important ones are distance and bandwidth. And now let's talk about some of the cons with fiber. The first con, which almost everybody brings up with fiber who doesn't know about fiber, says, well, fiber's expensive, I don't want to deal with it. And this is a really important con to talk about because there's two different ways to look at it. If you're talking about transporting, let's say, a microphone signal, from the microphone from your Shure SM58 to your mixing board, well then yes, using fiber and fiber converters and transmitters is ridiculously expensive. However, once you start talking about moving a lot of data around, so we talk about the sort of data you would transmit over Cat6, or we talk about video signals, or we talk about lots and lots of audio signals over, for example, if it's a live audio console, using this MADI interface, multi-channel audio digital interface. Once you're moving 64 channels of audio, or you're moving a lot of video, or you're moving a lot of data, well then suddenly the equation really changes, because now you're at a point where you're talking about having to use multiple cables and in the copper world as opposed to one cable in the fiber world. So this perceived con that fiber is expensive is false, because it's not expensive in a case where you do need to move that much data. Make sense? If you don't have to move a lot of data, right, use copper. But if you do have to move a lot of data, fiber can wind up being the more economical choice in many cases by far.
I'm going to interrupt you, Fred, if you don't mind. There is a question. Somebody has seen conflicting information where some people say fiber is still affected by EMI and EMF due to sine wave, being transmitted. Is this true or is it untrue?
All right. Well, when you're still in the copper world and when you're what's called the transceiver world, the transceiver is the device which converts from copper to fiber. When you're still in that world, all sorts of bad things can happen based upon EMI. But once you're transmitting light, you've got to remember that transmitting light is the same as using a flashlight. When you're transmitting light, my understanding is there is no possible way that you can affect that light through electromagnetic radiation. None. And I'm happy to take a follow-up on that. I don't want to bog us down, but if there's a conversation we should have there, I'm happy to have it.
Okay. I will let you know if something else comes in, but if you would like to move on, that's fine.
All right. Sounds good. And again, I just want to point out that the people who are using fiber are always tremendous evangelists for this advantage. They say, well, it's wonderful. I don't worry about that stuff at all anymore, at all.
Great, thank you.
Perceived con number 2, that fiber is fragile. And here's where I really wish I could get my webcam going. I could show you some of these things. This cable that I show up on the top is a good example of a non-rugged fiber optic cable. You buy this stuff off eBay or from BTX. It's kind of a more or less commodity item, and it will cost you $20, $30 for a cable like this. So this idea that fiber is fragile, if you get one of these fiber cables, which is really designed to connect a couple computers together, or connect back in the data center, or for a permanent install, you're right. I mean, this stuff with these little connectors, this is fragile. You've got to be really careful with it. It's definitely not roadworthy. However, once you look at rugged fiber optic cables, and that's what I'm showing with the cable down below. Can you see my mouse moving around here on the screen?
Yeah, Fred, I'm sorry. I have myself
Okay.
muted so that they can't hear
Gotcha.
me breathing.
Right. Yes, thank you.
Okay.
Right. Okay, so you know, this cable that you see here, this is an example of a rugged cable, and these rugged cables are many hundreds of dollars or over $1,000. But this stuff is the stuff that, you know, is not fragile. So it's deployed in Iraq and Afghanistan. It's used in war zones around the world. It's highly crush resistant. The connectors and the strain relief on here are super rugged. There's always some protection schemes for the fiber end, you know, for that very little end there, which could, you know, potentially get scratched or could get dusty. You always have this kind of protection. So once you move in the rugged fiber world, it is unfair and untrue to say that fiber is fragile. You've got this real distinction between non-rugged fiber and rugged fiber. And then I want to make the point with a couple slides coming up here that high-density analog solutions, you know, these multi-pin solutions, are actually more susceptible to damage than rugged fiber solutions like opticalCON. So let's take a look at some slides and let's take a look at some of these connectors. And some of you may have had some experience with some of these connectors. This is the ALCO EDAC connector. And, you know, pins bend in here. These connectors get damaged over time, and when they do, they are a tremendous pain to repair. Here's another example. This is the RAM latch connector, which is this is just an incredibly hard connector to terminate. And again, you've got all of these different metal pins in here, and nothing against, you know, the ALCO or against the RAM latch or anything that I'm showing here, but, you know, these are pins, and pins bend and break and have problems and corrode. So, you know, these are not foolproof connectors. They're good connectors, we use them, but they're not foolproof. This is the mass connector, which again, lots of pins, lots of sockets, possibilities for misalignment, possibilities for corrosion. And then we take a look at fiber. So what I'm showing you here, which is opticalCON, is a fiber optic solution. You just have a lot fewer parts that can cause problems. So right in here, this point and this point, these are the two areas where the fiber would connect. Now we were looking at connectors like the ALCO or the RAM latch connector with maybe 150 connections at the most. Well, here the equivalent number of connections over fiber is tremendously higher. That equivalent number of connections is made using fewer mechanical parts. There's fewer parts that can fail. And again, it's rugged, it's wrapped up in metal, it's protected. So, you know, when people say fiber is fragile, okay, I can buy that argument. But let's be clear that copper is also fragile. And they're probably fragile to about the same extent. I think our statistics will show that a rugged fiber solution like opticalCON is probably a little bit less susceptible to failure, but you know, we can for the sake of argument, we could say they're basically at par, which I think is a fair thing to say. If anybody wants to object to what I've said, by the way, I'm happy to have a discussion. So ask a question of Kim, and she'll relay that on to me. Another perceived con about fiber, this is a little bit outside of our area, but the tensile strength of fiber, in other words, the pull strength, if you were to pull a cable, the pull strength of fiber is actually higher than that for copper. This is sort of a surprise to people that, you know, if you pull on glass, it's going to be harder to pull the glass apart than if you pull on copper. The copper will shred more easily. So this example I show is, you know, people that are doing these things where they're really doing very, very high force pulling. Probably for some of our attendees, you know, you do also have areas where your pulling is quite high force and you're concerned about it. And again, fiber is superior in this case. I like this little statistic here. Rugged fiber has 8 times the tensile strength of Cat 5. That's great, and it's valuable because, of course, you know, pulling is something we do. By the way, I should just step back and say, you know, when we talk about fiber optics, we're talking about transporting light over glass. It's glass fiber. So you'll hear me say glass and fiber sort of interchangeably. Perceived con number 3, fiber is difficult to terminate. Now, okay, this con is absolutely true. And this is a big issue for a lot of users. A lot of people grew up thinking, you know, or grew up in the industry thinking, I have to terminate my own cables and I have to be able to repair my own cables. It's an absolute requirement. And I understand that. You know, I've terminated a lot of XLRs and quarter-inch cables in my time, a little bit of Cat 5. So this is true. You know, the industry, our AV industry is changing, and we're adopting so many of these different connector types that come from different industries, like consumer AV in the case of HDMI, the computer industry certainly in the case of Cat 6, the telco industry in the case of fiber. And, you know, terminations are becoming more complex. I think that those of you who do your own terminations know that because you've added more tools for more different types of connectors in your toolkit. But once you move to fiber, it's true. It's different. You look at a company like BTX, which is doing a great job with opticalCON. They've had to invest tens of thousands of dollars of equipment just to do it. There are field assembly versions that you can use to terminate fiber, but they're not as good as factory termination. And so this is a disadvantage. There's some ways around this disadvantage, but it is definitely true. It is a con for fiber that it is more difficult to terminate. Now, we do talk to some people who say, if I can't terminate it, I'm not going to use it. And we say, all right, well, let's see how your business goes when your customer wants to integrate HDMI. You know, unfortunately, maybe it's one way to put it, maybe it's unfortunate or not fortunate, the industry will, we believe, continue to move towards connector types which cannot be self-terminated, cannot be field terminated. It may be good or bad, but for bandwidth reasons, it's inevitable. So we have to see it happen. Maybe you can let Kim know. I'd just be interested. If you terminate Cat 6, why don't you, let her know whether you're a Cat 6 terminator, because Cat 6 is hard, and we'll ask. We'll find out here. Of the 55 people on the call, how many terminate Cat 6? So just interrupt me, Kim, when you get that answer.
I will. Thank you.
Thank you. And perceived con number 4, that fiber cables require esoteric cleaning. Dust and dirt block light. They are the enemies of fiber optics. This is so important. Let's be sure that we're very clear about this. Right? When you're talking about fiber, you're just talking about, it's like a flashlight. You're shining a light through, and if you were to put some sort of, if you put your hand over it, you have some sort of occlusion, some sort of dirt. If you have some sort of scratch, that's going to block that light, and that's going to completely block the signal, or it's going to seriously degrade the signal. So therefore, we've got to keep these fiber ends protected, and we've got to keep them clean. So cleaning fiber is different from taking care of copper. First of all, you got to think about it, which you don't have to do with copper. And so to that extent, it's true that fiber is generally harder to take care of than copper, so long as you keep copper out of very salty and very wet areas. So we need solutions for cleaning. And as we talk about opticalCON, we'll get into how opticalCON is actually designed from the beginning. Part of its design brief is that it had to be easy to clean. So let me just kind of talk through this part here. That opticalCON keeps the fiber clean by having some shutters. We'll look at these shutters in more detail. By having different dust caps, and they're also opticalCON's also designed to be very easily disassembled, so you can clean it with standard inexpensive stick cleaners and Kim wipes and these sorts of things. I will say that in the pro AV world, most of us are aware that we have sort of a roadie mentality. We're not fastidious people in pro AV. It's always interesting to me how many people have used our solutions for years, our fiber optic solutions for years, and in very heavy usage, and never ever clean them, never monitor them, never clean them. This is not best practice, but I'll also have to say it's standard practice for people just to deploy this stuff and not be concerned about it. We want you to learn about cleaning. We want you to know how to clean, but it's also important to know that you can install this stuff. You can send it off to a client. They can use it for many, many years with no problems. And so it's part of the reality of fiber. All right, Kim, how many people terminate Cat 6?
About 75%.
Okay, gotcha. Interesting. All right, so you all know that it's tough to do, and that connectors are getting harder and harder. You will eventually hit a point where you say, and maybe it's HDMI, somewhere where you say, all right, it's just not worth it for me to terminate this. Good. Well, that's a sign I've got a very qualified group here. I better up my game.
Right. There you go.
Yeah. So, all right, another con here that is often discussed is that, boy, if you bend that fiber, if you just bend it the wrong way, you can disrupt or you can stop the signal. So this is old thinking. There's this new stuff called bend-insensitive fiber, which is really becoming more standard. The glass manufacturers are getting better at making types of glass which will resist attenuation when the fiber gets bent. So with this sort of the generic stuff, the non-rugged stuff, you can now tie this up in knots like this, and you generally don't have serious problems with the modern stuff. Now, a big difference is once you go to rugged fiber optic cabling. You remember a couple slides back we talked about this distinction between non-rugged and rugged. When you're in the rugged world, this stuff is wrapped up in this aramid yarn here. This is it would be called Kevlar or made by DuPont. Since it's not made by DuPont, it's called aramid yarn. And then a very thick PUR polyurethane jacket on top of this, and the fiber protected inside there. And so one result of this construction, we'll talk more about this construction later, is that it's actually impossible to take this cable and really very, very tightly bend the fiber. You've always got some built-in radius because of the aramid yarn and because of the jacket. So this stuff you have to really torture in order to get some serious signal degradation. So, is it true that bending fiber cables can disrupt the signal? It's true. However, I say that this perceived con is false because in this case you have to really sort of intensely try to disrupt that signal once you're using this rugged fiber. Again, a big point about this presentation is when we think about fiber, always make the distinction between the non-rugged stuff and the rugged stuff. They're very different principles and ramifications for using each. Okay, perceived con number 6. This is sort of like the catch-all one. We talk with a lot of people, or I should say we did, because this is declining, who say, fiber optics are just avant-garde, they're scary, it's something new, I don't want to deal with it. So a couple points about this. First of all, you've got now experts like BTX, like Neutrik, who are here to help. We're here to help you make the transition, because I got to tell you what, you have to make the transition. Unless you're very close to retirement age, you'll be working more with fiber with your Crestron and Extron systems, with your digital snakes. No matter what part of the technology you're in, you'll be working more with fiber. And our assumption is that this 4K video thing, which is going to, presumably come into the market, is going to accelerate this trend as well. So, fiber's coming. We're here to help. But then let's talk about the reality. The reality is, and by the way, this article is from, I believe, 2011, that 40% of the cabling installed in the data center is optical fiber, and 20% of the enterprise cabling is optical fiber. These rates, I'm sure, must have gone up by now. And then just to kind of give you a point that I have, and I hope I'm not going to ruffle any feathers by saying this, but I go out and I visit a lot of system integrators, a lot of them. And there's sort of a distinction. The ones I visit who are embracing fiber, using fiber, they are, with very, very few exceptions, doing very well. Their business is going well. They have lots of clients, and they have lots of jobs. By contrast, when I talk with system integrators who say, no, you know what, fiber's not our business, we're just not in that, these system integrators are either doing only very, very small jobs, and by that I mean smaller than a high school. They're doing home theaters, or they're doing, residential sort of stuff, or they're in the larger market and they are not doing well. So I'm not trying to be scary, but this is just something that I've seen, which is that, you're either on board this train or you're getting left behind. How's that? And,
Get on board.
Right. We're Neutrik. We're very happy to sell you all your XLRs and Cat 5 and Cat 6. I mean, we're very much in the copper business, and copper is by far the dominant part of our business. So we're going to win either way with you, we think, and same for BTX. But really, if you're resisting fiber, you should know that your competitors are racing ahead, and it's time to catch up. I believe. Before I move on to the technical basics of fiber, let's just take a quick break. And if you have any questions or complaints, let Kim know, and we'll take a look at them. Otherwise, Kim, let me know when we're good to go forward.
Okay. You know what? Let's just see. We do have a question. Let me see if I can. So somebody said, I think to your statement, some projects just don't have the needed distance benefit for fiber.
Right.
They haven't tripped upon that. So just a statement to your conversation.
Yeah, let me talk about that. It's a really important point. We don't want you to over-specify fiber. It's not in your interest or your client's interest. Cat 5 and Cat 6 are great solutions. Multi-core snakes are great solutions. A reason I bring up these distance limitations is I want to try to help you understand where you do need to move to fiber and where you don't. Our point here is not use fiber everywhere. Our point here is use fiber when it's appropriate.
Sure.
Yeah.
Sure. Yeah, somebody made the statement, it is more critical in the broadcast environment. That's where they see a lot of it. And somebody also said, that it would be nice to see the statistic that you just gave on fiber deployment more recent. So I will let
Yeah.
everybody know that I'm sure either Fred or I will see what we can find out there with some of the main
Right.
publications to see if they've done something more recently, and I'm sure they
Yeah.
have. So
I will look. I'm taking the note now. It's a good point. Yes, hopefully I can find something good. All right, good. Well, let's talk about the technical basics of fiber. What is this stuff and how does it operate? So, see if I can use my computer. All right, the fiber optic light spectrum. So, fiber optic is light, but that doesn't mean you can see it. So, if you take a look at this this image here, you see the visible spectrum, right from red up here to violet. And by the way, this gets to these phrases. Ultraviolet is stuff that you can't see because the spectrum is too high, or we could say the nanometer size of the wavelength is too small, so we can't see it. Ultra, right, above violet. And we talk about infrared, I-N-F-R-A, which is below red. Well, that's still light, but that's where the size of the wavelength is so big that we can't see it. It's still happening. It's still there. It's just that we can't perceive it. So that's why this part is very important. Never look into a live fiber optic cable. I cannot emphasize this enough. People who are new to fiber say, well, I wonder if this thing is working. And they'll look into it, and, well, they can't see anything, but that doesn't mean that it's not transmitting signal, and that signal is not burning into your corneas. You can certainly damage your eyes if you stare into this stuff for a long period of time. So just never do it. Make a point never to do it. Now, this gets a little tricky because for those of you who have maybe some fiber optics with your home theater, you've got that plastic fiber optic cable for to go from your TV to your sound bar or something like this for SPDIF applications. That uses red. You can actually see that light on those. But that's a different type of technology from what we're talking about here. This type of technology, like I said, you cannot see it. So you've got to provide some protection against it. If you take nothing else away from this presentation, take this away, which is do not ever look into a fiber optic cable if you have any concern that it might be live. Okay, hopefully we can take some more out of the presentation, but that's an important point. Let's talk about some more technical basics. Connector types. We all know that in the CAT world, we standardized on the RJ45 connector. Now, RJ45 is probably not a very good connector, but at least it has the advantage of being standardized. We use it all the time. In the fiber optic world, by contrast, we never standardized on a connector. So in this photo, you see ST, SC, FC, LC, a whole bunch of different types. They are all standard. There is no one standard. They're all used. And so this is important to keep in mind because, just know that there's not a connector standard. Now, having said this, what really matters is not this white thing here, which we call the ferrule, but within that is the glass itself. And it's that glass which is sending the signal through. So, here's this white ferrule you can see here. And then on a different connector, here's another white ferrule. And on a different connector, here's a white ferrule. But, they're all doing the same thing, which is they're all aligning that glass. So it doesn't really matter what connector you have on either side. You just have to, the point is you can mix and match these connectors on either side. So you can have LC on one side, SC on another side, whatever you want to do. It doesn't matter as you're connecting this equipment up. It's unfortunate that we never standardized on a connector, but we haven't, and I have to say it doesn't look like we're going to do it. This connector here, ST, some people consider to be a rugged connector. It's not technically a rugged connector. It's used a lot in broadcast. It's sort of, it's got some metal, so it's sort of like rugged enough. But you see it still has all this exposure of this ferrule. So just know that, sometimes you'll see a lot of ST used in broadcast. In Europe, it's no longer used. In the U.S., we still use it. Our belief is that the ST connector will disappear from, rugged broadcast type of use in the future. It does have the advantage of being metal, where these other ones tend to be plastic. And then cable jacket types. All right, so there are three basic types of fiber optic cable jackets. There's There's the PVC jacketed stuff. This is the standard stuff that gets pulled through conduit. Plenum rated, and I think probably most of you know about plenum rated cabling generally. This is stuff which is non-toxic, so that when your air conditioners or your heating devices are blowing over these cables, they're not putting out gases which could be damaging. You should know that, by the way, in opticalCON, we have no plenum rated fiber in opticalCON. We don't need it because we're not, opticalCON, which is the Neutrik solution, is not designed for these permanent installs. It's designed for patching from place to place to place. which does not need deployment ratings. And then there's this tactical fiber. This is the stuff that we've been looking at. Again, it's Kevlar reinforced, or again, Kevlar is the same as aramid yarn, same stuff. The tactical fiber, which has got the exceptional pull and crust resistance. So let's take a look at some of these here. I just want to make a quick point about this stuff here, this plastic optical fiber. We're not talking about this today, but people often think that this is what we're talking about when we talk about fiber optics. This uses plastic. It does not use glass. It's got a very, very highly limited bandwidth. It's fundamentally different from the fiber that we're discussing. So I just want to make this point. Hey, I've got this stuff at home. You may have this stuff at home as well. You may even use it in your pro installs. But these are this is for very short, very bandwidth limited connections, not like the fiber we're talking about. Okay, let's talk about multi-mode and single mode fiber cabling. And to do this, let me kind of give you some background. You can imagine that when the engineers at Corning and other companies first figured out how to shine light through a piece of glass and get it to the other side, this was a fantastic achievement, a magnificent achievement. But you can also imagine when they first did that, they had to use a relatively large piece of glass, and the light didn't really go straight through. It kind of bounced around, and it made it out the other side. This is essentially what multimode cabling is. So multimode is an older standard, and by multimode, when we talk about modes in fiber, it's equivalent really to talking about frequencies in audio. So it's multiple light frequencies that are sort of bouncing back and forth and recombining and going forward. So multimode, which is this older style of cabling, still used quite a bit, basically kind of bounces this light up and down through the glass, and it comes out the other side. And it's great. It works well. There are two current standards. One is 62.5 micron. Micron is this unit of measure. 62.5 micron, which is an older standard. It's disappearing. When we came out with opticalCON in around 2007, we decided not to support it because one advantage of Neutrik is that we're so big that we actually help propagate standards. When there are standards, we can help reinforce those standards. So we said, well, 62.5 is on the way out. We won't use it. And then there's this 50 micron core size, a smaller size, which it turns out, it seems like the difference between 62.5 and 50 micron would not be that much, but there's a tremendous technical advantage in the bandwidth that you can achieve and the distances that you can achieve when you move to 50 micron. So in the multimode world, we support this 50 micron core size. And then you can imagine that what's happened to glass over time is that just like all of the processes, they've been able to make it smaller and smaller and smaller and more efficient. And eventually they got down to a 9 micron core size. And at 9 microns, suddenly they can do something which they could not do with multimode cabling, which is rather than kind of bounce this light up and down across the borders of the glass, or the margins of the glass, well, they could just shoot a photon, or I shouldn't say photon, but they could shoot a light stream directly through that cable like a bullet. So you see in this image here that we're no longer bouncing the light up and down on the glass. It's shining directly through like a bullet. And this is the reason why single mode has 10 times the distance as multimode. It's a much more efficient way to be able to move that light from point A to point B without the kind of losses that are involved in the light dispersing and having to sort of bounce around the glass. By the way, for those of you who are extremely technical with fiber, you're aware that I just gave a simplified discussion of multimode and single mode. But this is important to know. We have these two different types. Whenever you implement fiber, you have to choose one type or the other. So let's talk about the trade-offs of these. Multimode has some tremendous advantages. One is that the light can be sent with these very inexpensive transceivers. Remember, a transceiver is a device which is copper on one end, or electrical on one end, and optical on the other end. It's transceiving. It's changing that signal from an electrical signal to an optical signal. So multimode's advantage is it can use this really inexpensive transceiver. Its disadvantage is, again, because it's bouncing that light back and forth and up and down, is that you've got this this lower range. We'd say typically think about a mile. There are all sorts of different caveats here and all sorts of footnotes I put in here, but they can basically be ignored for the sake of this conversation. And then by contrast, single mode requires really expensive laser-based transceivers. You can't use an inexpensive transceiver. You need a more powerful thing. But then the advantage is that laser-based transceiver can help that signal travel a lot further. So again, this 12.5 mile limitation. I think the best example I can give of how these different ones are used is golf courses. When a broadcast company goes out and they cover a golf tournament, the cabling can be miles long. And for that reason, they use single mode for golf tournaments. And for that reason, when SMPTE established the standards for fiber connections to cameras, they used a single mode standard because that increased distance was important for these camera operators. It's a drag that with multimode and single mode cabling, we have these two different standards. You cannot tell other than by reading the cable jacket and from some sort of subtle color coding which is which. But this is the situation we live under. In the system integrator world, we typically have used a lot more multimode than single mode because it's been less expensive and because we've not needed those long ranges. That is changing a little bit over time. We'll talk about that. But you know, typically the old way of thinking was if it's broadcast, if it's cameras, it's single mode. If it's anything other than broadcast, and if it doesn't require long distances, it's multimode. That's been the typical way of thinking about what you should implement. And of course, BTX is happy to help you discuss this. If you have any questions with your particular installation, I'm happy to discuss this with you as well. Hopefully we'll have those discussions. Okay, more about multimode and single mode. You cannot mix and match. They are different types of fiber. And if you do try to couple one to another, you can result in an almost total attenuation in some circumstances. I got to put in a lot of caveats. It should not work when you put multimode and single mode fiber together. You will have some tremendous losses. But having said that, there's sometimes where the power budget is so high that you can sustain these sort of losses. Anyway, don't do it. So if there's anything else to take from this conversation, again, the first thing is don't look into a fiber that might be live. The second one is always ask your clients, do they require 50 micron multimode or single mode fiber? And I put in that 50 micron there because they might say multimode, we have to be careful they don't accidentally specify 62.5. It happens very rarely, but about once a year I get a call from someone that, they installed 62, they pulled 62.5 micron fiber, and then it turns out that all of their equipment and all their other cabling requires 50 micron fiber. So, again, just remember this question. Do you require 50 micron multimode or do you require single mode? If your client doesn't know what the answer is to this, and often they don't know, ask them what their maximum distances are. And then as I say here, usually, clients should spend money for single mode equipment only if they need to do so. So again, if it's broadcast, something like that, okay, they need to spend the money. If it's not broadcast and they have an option, if they don't have long distances, they will typically save money with multimode cable. I just want to take a quick break here and ask if there are any questions. I hate talking without getting questions back. So any questions from anybody?
I haven't seen any come in. Whoops. But now we do. Is there any hope? Is there any hope of MADI equipment migrating from multimode to single mode in the future?
Oh, this is a great question. All right, so let me talk quickly about MADI. This question came from an audio person. The multi-channel audio digital interface standard can run over either CAT cabling by Cat5 or can run over fiber. And the standard is 64 bidirectional channels, 48K. And then I want to say what's the, I'm sorry, is it 44.1 or 40? Anyway, it's a 48K standard, 64 bidirectional channels. There have been discussions, and I'm a member of the AES Fiber Optic Committee, of changing the standard because the truth is the fiber optic transceivers have now gotten so much faster that it's hard to even find the older transceivers, and they're getting more expensive, which handles such little data. So there is talk about a MADI 2 standard, which would, amongst other things, dramatically increase the number of bidirectional channels dramatically, which would be easy to do. I mean, technically, we're already there. And that also would even potentially allow either multimode or single mode to be used. I have to say, and don't publish this, don't put this on Facebook or your blog or anything. The committee has been very, very slow in coming up with a recommendation for this that would then go into the committee and become a certified standard. I believe honestly that this is going to be very similar to a lot of other standards from AES, which is that the manufacturers are just going to make a change and they're going to implement their own standards, and AES is going to kind of follow up on this. I think the best example I have of this is that it was just in 2012, I believe, that AES finally standardized the RJ45 as the connector to be used for Ethernet-based audio transmission, which is just shocking to me it's taken this long. And also in 2012, the AES finally standardized a pinout for DB25. So AES is typically a real laggard in these things. It's disappointing. AES, I think, should be more aggressive. But to answer that question more directly, there are going to be manufacturers, and I think what SSL recently did with their live console is a good example, that are going to basically just bypass the standards and they're going to do what they have to do. It's unfortunate in the case of interoperability. It would be nice if we did have these standards, but I don't see it coming.
So just a quick, cute follow-up from that. He said it's the question's coming from a video person who hates to run into multimode on job sites.
There you go. Right. Well, see, the video people are always single mode, and they've got good reason to be. The mixed AV people are typically multimode. They've got good reason to be, and it's a problem. Probably over time, multimode will fade out, and we will migrate to single mode. This is the expectation. But when I say over time, this is a long sunset. 10 or 15 years or something until the default idea is single mode. And this is also hampered by the fact that there's so much installed fiber.
Sure.
And there's a lot of installed multimode in cases where there's not installed single mode. I should make the point here as well, by the way, that if you are installing fiber in a permanent install, you're dragging it through the walls, taking it through conduit. Our position is, and hey, it's not our money, so it's easy for us to take this position. Always install some dark multimode and some dark single mode fiber. Just pull them both. It's not that expensive. Hopefully you can get your client to budget for it. And then you're really future-proof no matter what happens. I can't tell you, I've had a lot of conversations, I can't count how many, with people who say, boy, I went to the job site and the equipment was supposed to be multimode, but it came in single mode or vice versa. And thank goodness there was this dark fiber there that we could terminate on the site, and we could get the equipment running, and the client never knew that there was a problem. I think this is a wonderful thing to pull both single mode and multimode.
Great.
Anything else, sir? That was a very good question.
There is another. I'm actually working my way down the list. In my experience, RF signals over fiber always use a single mode no matter what the distance to increase reliability. Do you find this is the case, as I have never seen multimode for RF over fiber?
Well, okay, now we have to be tricky because RF, of course, means radio frequency, and that means you're talking about the electricity side of this as opposed to the optical side of this. But if we talk RF, typically we talk video, and so typically we talk single mode. Have I seen multimode equipment used for video? Yes. We see actually a lot of it with these, for example, these OB vans where people are trying to reduce costs and be able to put out a high-def outdoor broadcast van which doesn't cost too much money. We see it with some of this equipment. I want to say, by the way, I think that both Telecast and Telemetrics offer multimode options for their boxes, which will then connect up to other boxes. But the connection to the camera is typically single mode. So to be more clear in answering the question, I think 97% is single mode, but I do believe that there's some multimode out there. Another good question.
Great.
By the way,
go ahead.
Sorry, let me just say, one of the great pleasures I have in my job is I talk with so many people. I get so much input that, it's just wonderful. I'm learning all the time what different people are doing. And so it might be that this 3% I'm talking about is, real corner cases. Might not be up there. But I can say that, I've heard it, and I talk with different companies that are doing these sorts of implementations.
Great.
Kim, sorry, go ahead.
I believe that that was the last question. I have just a side note, Fred. Sorry. People every now and then are saying that they're losing the audio, and that we're not having that problem on this side. So I'm not sure if it's an internet connection, but 2 different companies have said it. Just if you have it, just hang on a second if there's an issue, and it should come right back. So just a bandwidth issue, I would suspect. So. Sorry, Fred,
and
go
of course,
ahead.
Everything I have to say is very important. So
you don't want to miss a minute. Don't want to miss.
Yeah, I do feel bad if that's happening for you. All right, good. Well, let's keep going here and talk about some other things. Remember I talked about transceivers. So here's a nice little picture from the internet about the transceiver. The only thing that matters here is that you know that there's such a thing as a transceiver. It takes electrical signals here on this side, and it converts them to optical signals. And you see these transceivers are typically, you know, what we would call 2-wire on the copper side and 2-fiber on the optical side, so that you've got, you know, this output side, and then you've got this input side here. There is no fiber optics without transceivers. Everything starts electrically. For you audio guys, you know, we always like to say in audio that, you know, it all starts and ends analog. Well, okay, once you get past analog, then, you know, you can also make the point that everything starts and ends electrically, and this optical signal is really just a carrier to get from point A to point B. And again, here I'd say there are both multimode and single mode transceivers. There are now even transceivers which will do both, but now we're getting a little bit esoteric, so we'll leave that for the time being. Transceivers are commodity items. So I just went to Amazon, and I just wanted to show this here. So here's a 1 gigabit multimode transceiver, $37. I don't know if you can see that. It's pretty small. And here's a single mode 1 gigabit transceiver, $39. And these are things, by the way, that you would typically stick on a PCB here. I mean, you see here these pins are designed for PCB mounting. So a couple things about this. First of all, it's just a commodity item. It's not an outrageously expensive thing. The second thing to know is you see that this cost differential is really collapsing between multimode and single mode. So it used to be that single mode was far more expensive. If you look at these prices, now I could say, well, look, I mean, if I want the benefits of single mode, it's probably not going to be much more. This is a change. This is a big change over the last really year to 2 years, and this will trigger a change in how we talk about multimode and single mode in the future. We're going to begin to say that, you know, they're basically on par price-wise, but we can't say that quite yet. Okay. Typical performance per transceiver type. Boy, now's when you probably wish you didn't attend this seminar. But I'm not going to go through this. This is just if people really want to know. You can see these different bandwidth possibilities for different types of devices. Let's just all do ourselves a favor and not look at this slide. All right, but this part is kind of important to know. There are different polish types for these cable connectors, or really I should say for these ferrules. So typically a ferrule is just a very slight dome. It's very slightly domed here, so that the you know, at the center of the dome obviously is the fiber. So there's what we call physical contact polish, ultra physical contact polish, which is basically the same thing, only they made it better. And then this thing, what's very interesting, called angled physical contact. So for those of you listening, if you take your two finger, your finger from your index finger from your left hand and right hand, you put them right together, you would think that, you know, pointing right at each other, that would be the best way to transmit light, was just, you know, right through. But it turns out if you actually angle your fingers a little bit, or angle this fiber a little bit by about 8 degrees on each side, you get less back reflection. So imagine if you're shining the flashlight into a flashlight, you know, that lens on the flashlight is going to reflect back a little bit. And that's also true with the polish on the fiber. So if you angle those lenses a little bit, then you're not going to get that back reflection, and you're going to have a stronger signal, even though, you know, you've misaligned on purpose a little bit. This angled physical contact
Fred? Fred? Can anybody hear me? Okay, so you can hear me. All right, you know what, everybody, I'm sorry. I'm going to just see if I can quickly get in touch with Fred, because he probably isn't picking up his cell phone. Interesting. Sorry, everybody. I'm just going to mute myself just to see if I can get Fred. So just everybody hang on the line just 1 second.
Oh, hello? I'll bet now you can hear me.
I was just getting your cell phone number to see if I can get you. So I think that we lost you. If you back up a slide.
Okay, boy, I really apologize for that. I think
That's
that
okay.
was something I did here.
Boy, I'll tell you what, you woke everybody up if they were trying to sleep.
Okay. Good.
So
Right.
we ended at the angled physical contact, kind of right in the
Okay,
middle
good.
of that. Okay.
All right. And did you hear my finger discussion, the
I
lenses?
did, and I was actually doing it with my finger, just so you
Okay, all
know.
right, very good, very good. Okay, so I guess the point to make here is that this angled physical contact is a better type of polish. However, even though it's widely used in Europe, it is essentially not used at all in the United States. To the point where about 2 years ago, Neutrik stopped even stocking angled physical contact connectors because it's just so rarely used. It turns out that the standard PC and UPC contacts are more than good enough for the power that we require to transmit, through the fiber. So, anyway, this is something to know that there are these different polish types. In the U.S., you're basically going to be using PC/UPC polish. These are basically interchangeable. Okay. So let's talk about color coding. This is kind of important. Again, you can have a cable, it can be multimode, or it can be single mode, or it can be single mode angle polish. But the question is, well, which one is it? How do you know? So there is an industry standard. Actually, there are a lot of industry standards, as I kind of show here. But if you don't want to give yourself a headache looking at this chart, let's look right up here at these 3 gaskets. When you purchase opticalCON, it always comes with when you purchase one of these chassis connectors, it always comes with 3 gaskets. Blue stands for single mode. Black stands for multimode. Green stands for single mode angle polish. Now, as we've already talked about, you should take the green one and you should throw it away because you're not going to be using angle polish here in the U.S. You're either going to be using multimode or single mode, and you should put that gasket around that opticalCON chassis connector so that whoever is connecting to that knows that it's multimode or single mode. Similarly, here on your cable end, if any of you have purchased opticalCON, if you take a look at your cable end, it's always either black or blue, multimode or single mode. And this color coding right in here on the tip of the connector is also designed to tell you what type of connector you have. So, hey, there you go. Hopefully you've learned something. Now, we don't make things easy to the extent that we actually sell other gaskets like this in red and white and yellow that people use. A lot of people use these for sort of a custom coding solution, and that's okay. It's all right. But the intention and the reason why you get these 3 gaskets when you purchase an opticalCON connector is that we're helping you do your color coding to let you know, to help your users know what's multimode and what's single mode. Now, let me take a break. Let Kim know, for how many of you is this new information, the blue and the black and the green? And then Kim can let me know.
Why don't we give them a second? But I did get a couple of questions come in, if you don't mind answering while people are. When is UPC better than PC?
UPC is a great question. UPC is always better than PC. It's basically an iteration on PC. Most of us who do polishing, which we call PC, we actually now polish to the UPC standard. So these are practically interchangeable terms at this point. But having said that, if you're purchasing a connector and it says it uses PC, don't hesitate. It will be fine.
Okay, great. I have to tell you, everybody is saying it's new for them.
Hey, great. Okay.
Yay.
Well, let the record show this is not a total waste of time. All right, good. So yeah, good. That's what it's all about. I'm glad that came up. Now the rest of this is, it kind of makes the point that there's a lot of different standards, a lot of different colors that are used. But all you need to know in the opticalCON world, and mostly in the rugged fiber world, is blue and black. Okay, good. By the way, I have to say that a lot of our assemblers, like a BTX, are surprised. Oh, that's why that's blue.
That's why we get trained, right?
Right. I don't know if that's specifically true for BTX, but it does come up for other companies. Okay, and then there's a bunch of different technical varieties of cable. Again, I'm not going to go through this chart, but you can imagine the point is that cable has gotten better over time. That's the basic point here. Now we typically all use in our AV space this OM3 laser optimized multimode cabling. So this cabling is designed to be able to accept both those inexpensive transceivers and also more expensive laser transceivers. But in this case, laser transceivers. Laser transceivers which are sending it at the multimode frequencies and multimode size. Okay, this is an interesting point. So let's talk about this wave division multiplexing. Some of you are familiar with the word multiplexing, which basically means that you take a bunch of signals and you figure out some way to send them all simultaneously. Now, when you do that optically, it's really interesting. Remember that we're talking about light spectrum, right? From smaller frequencies to larger frequencies. So, just the way that I could shine a red laser pointer, or I could shine a green laser pointer. Well, I could really figure out how to shine a red and green laser pointer at the same time, and I can multiplex those on one side. So I take some data and I shine them across multiple different frequencies, and then I have a demultiplexer on this other side, which takes takes that signal and fans it out again. So multiplexing is a way that allows you to send dramatically more signal using the same amount of cabling. I have to say, from the Neutrik perspective, I'm unhappy with multiplexing because we used to sell 8 cables, and now we'll sell 1 cable, and people will multiplex, 8 light frequencies across that 1 cable. So it's really bad for our business, but it's really great for being able to transmit more data over a single cable. Again, by using different frequencies within the light spectrum. There are 2 different wave division multiplexing types. One is called conventional or coarse WDM, CWDM, which is up to 8 light frequencies. Another one is called dense WDM, DWDM, which is a newer technology that multiplexes up to 40 or even up to 80 light frequencies. Now, once we start talking about this much light, we're generally outside of the AB spectrum. I mean, we're talking about people that are doing, massive, like Google, sending lots and lots of data, at very high speeds. We typically don't have that need, but, never say never. There are some companies now which are implementing CWDM for digital snakes, and it's a very, very powerful thing for them to do, very powerful. And from the consumer standpoint, it's awesome. Your customers can have so much mixed, broadcast, projection, image magnification, multi-channel audio, data, intercom. So much data can be put on these fiber boxes and transmitted from point A to point B via wave division multiplexing. Okay. Now some more. So now we're kind of in the esoteric weird stuff. There's another esoteric weird thing which come out, which is bidirectional fibers. So this was always hard for me to understand. These special transceivers allow one physical fiber strand to both send and receive. So again, typically we use 2 fiber strands. One is a send strand and one is a receive strand, right? You send light from point A to point B on, sending, and you receive light from point B to point A on a completely different fiber strand. Well, now, we've talked about flashlights a little bit. Consider this flashlight analogy where if I've shone a flashlight at you and you shone a flashlight at me, well, you know what? Those flashlights actually don't block each other's light. The light just kind of passes right through. So this is, into the real PhD physics part of fiber optics. But it's coming, and you will have more and more devices where rather than have to use 2 fibers, you'll only need to use 1 fiber to do bidirectional communication. It's pretty cool. Okay, now let me just talk about a little bit more about different types of connectors. Every connector we've talked about so far is what we call physical contact connector. Now, it might be angled physical contact, but you can see here in this diagram, it's pretty clear what's happening, which is that you're butting these 2 different connectors up against each other. The ferrules are touching, and the light is being transmitted. There's another type of connector called expanded beam, and it's not a technology Neutrik supports, but I'd still like to talk about it. The idea here is that this connection point has an incredibly tight tolerance, but if you were to basically put a lens on each side of those, then that lens could magnify the light on one side and then could collect the light on the other side in order to be able to have lower tolerances. And then also the lens itself becomes the point of contact, and so there's an idea that maybe that lens is going to be less fragile than this little point. Now, that's not really fair to say because this lens is glass and these points are glass, so really that's the same. You do have some loss when you do this. You cannot collect all the light that you bring back in, but just so you know that there are these 2 different types of contact. There's the physical contact type, which is a much more common type, and there's the expanded beam type. For many years, this was associated with a company called Stratos. Stratos is probably the leader in expanded beam technology, but another company called King's, Telecast has a product as well, which does this expanded beam stuff. Okay, oof, boy, that was good. Let's take a break, and that's probably the hardest part of the presentation. all those technical basics. Again, any questions? Now's a good time to send those in, and then we'll leave the technical basics in the rearview mirror.
Haven't gotten anything new come in just yet.
Good. I've beaten everyone into submission, which is All right, so let's talk about opticalCON. This is Neutrik's solution, and there's some other solutions out there. I talked about Kings and Stratos. There's some solutions from companies called Limo, Canary. There's some other ones as well. So we're not the only players in the space, but I do want you to know what opticalCON has to offer and what opticalCON is really all about. So our product range consists of three families, I guess, within opticalCON. The first is opticalCON Duo. So it can take care of 2 fibers and also carry 4 copper wires, which are typically used for camera connections. This Duo line, which is send-receive, is typically used to connect equipment. And here's where, again, I wish my webcam were working. I can't get it going, but I'd be able to show you stuff in person. Let's talk about opticalCON. opticalCON always has shutters. There are shutters right in here which are protecting the fibers. So when you plug something in, those shutters will open up. But they're automatically closed all the time, which, again, protects against someone looking into that fiber. They're not going to be able to look into it. But more importantly, protects, or I should say as importantly, I guess, protects against dirt and dust just sort of floating in and touching those fibers and contaminating the fiber. There are shutters here. There are also shutters in here on the cable end. So if you're on this seminar, if you've not seen opticalCON yet, when you come to one of our trade shows, definitely come see us. Talk to BTX. Have your BTX rep come out and see you and bring a sample case so you can really manipulate the stuff in person. It's interesting to see how these shutters work. And then on the rear of opticalCON, and by the way, I'm sorry, here are these 4 copper pins, which are 90% of the time not used, but that other 10% are used for, again, camera connections and other connections where you want to power up a device. And then these slots, except these LC connectors. Remember we talked about how there's this tremendous variety of LC, ST, SC, all these different connectors. Well, in this case, you take one of these $20 data cables, you plug it right into the rear of opticalCON, and then you wire that up on the other end to your active equipment. And that's it. That's all you have to do to make that wiring happen. And then opticalCON is designed to provide that patch point. It will patch, from a chassis connector on one side to a chassis connector on the other side. opticalCON, everything we've talked about so far has really been about fiber transmission. opticalCON is really a patch point solution. It's to get from point A to point B, where you're going to do lots of frequent patching and unpatching, and where you've got to have ruggedness. Again, this LC connection behind the chassis connector makes sense because this is in a rack. It's immovable. You're going to reconfigure your equipment once in a while, but it's not a patch point. Where you're going to, again, do lots of, and so where you're not patching, use something inexpensive, lightweight like this. But where you are going to do a lot of patching, then use something heavy and rugged like this, where you don't have to worry about the connectors ripping off because you don't have a strong strain relief or something like that. All right, so highlights of opticalCON Duo are the shutters, which we talked about, a very, very rugged strain relief. There's a 3-part strain relief in this cable connector, which basically, you could hang off the ceiling from the connector and it's not going to rip out. For those of you who don't know, a huge part of the connector business is strain relief. Where do cables typically fail? Typically, they fail at the strain relief part. The connector rips off of the cable, and so the strain relief needs to be very rugged, very durable, very strong. Another highlight is this LC connector compatibility that we just spoke about, that you plug LCs in the rear. With opticalCON Duo, you can even plug LCs into the front. So you don't need to use the rugged cabling. You can use this inexpensive cabling to patch the stuff up. And I can give you an example of this. I had a big broadcast studio in LA that loved opticalCON, but for sort of a special panel they were making, which is not really their core business, they loved opticalCON for the shutters, the built-in dirt and dust protection, but they just felt that they couldn't afford all of this rugged cabling. So they purchased 140 of these chassis connectors, and they purchased a huge number, like over 1,000 of these cables, thinking like, well, they're pretty inexpensive. We'll just use them until they break, and then we'll throw them away, and we'll use another one, and we'll keep using that until they break, and go forward that way. And that was a very reasonable approach for them. It made sense. So, something to think about as well, that you can have the benefits of these shutters, the benefits of the dirt and dust protection, and the benefit of the easy integration of your equipment while using this opticalCON Duo. You don't need to go whole hog and buy this really expensive stuff unless, again, you need it. All right, so anyway, other highlights of opticalCON Duo. The D-size chassis connector, we try to fit everything in that D-size, which Neutrik invented. With the same size we use for XLRs and EtherCon and quarter inch and pretty much everything else that we have. And then we have this IP65 protection when the cable is mated, so it's a great solution for outdoor use. Good?
We did get a question in.
Good.
Is expanded beam better for dirty environments? Are there less issues with from contaminants when using it?
Yeah, this is a great question. And before I answer this question about expanded beam, I want to be very clear that I'm a Neutrik person, Neutrik doesn't offer expanded beam, so we are biased. Your best answer is going to come from speaking with Stratos, which is really an expanded beam dedicated company, and from speaking with us. From our perspective, and again, I'm going to try to be as unbiased as I can be, expanded beam sounds like a fantastic idea because you've got these big lenses, you've got less issues with alignment, you should have more safety, it should be easier to clean, you're cleaning a great big lens rather than a tiny ferrule. It all seems like it makes sense. But when we talk with long-term users, they say it turns out that the idea that this stuff stays so clean is not necessarily so true. It doesn't stay as clean as you think. There are alignment issues. There's a lot more attenuation at every connection point. I think that the standard attenuation that they have is something between 1.5 or even 2.5 dB loss at every connection point. It's a lot more compared to maybe a 0.3, 0.5 dB loss on a non-expanded beam connection. So the industry generally feels that expanded beam had a lot of promise, but it just didn't really work as it was advertised. And again, I would encourage anybody also to talk about this with Stratos. But then, for a real perspective on this, talk about it with other people in your industry. One thing you will learn is that expanded beam connectors are declining in popularity dramatically. It's a shrinking business, whereas this physical contact, which you would think otherwise, well, maybe it wouldn't be as good. The physical contact business is really expanding. So physical contact is winning, and expanded beam is becoming more, it's just becoming less used. Now I want to pause here because if anybody wants to challenge the statement, I'm very, very happy to take the challenge and respond to it.
Give people a second.
I never want to come across as too biased. I've worked for Neutrik. I love Neutrik. I think we have great products. I don't ever want to slam another product, though, and I want to be accurate in this information.
Doesn't look like anybody's challenging you just yet, Fred.
Okay, well, I'll wait for the challenges to come up. But it's a great question. It's a great question. So let's keep talking about the product range. We also have this opticalCON quad. So you can imagine we came out with opticalCON duo, and people said, boy, that's awesome, it's wonderful, but we need more fiber strands. So opticalCON quad fits in the same D-size housing. You still connect LC connectors right in the rear of it, so it's very easy to connect up. We had to remove those copper pins because there was just no more room in the D-size housing for that. And then there's still a shutter, but you see here it's basically just like one big flap. And here it's also one big sort of levered flap, which provides the shutter protection. So it's still IP65 rated, it's still very rugged, it's got all those other advantages, but it allows you to transport more data. It's interesting, our quad sales are really increasing, I think even faster than they're all increasing, but I think our quad sales are increasing faster than our duo sales. Because once people see that opticalCON is this way that you can patch equipment together, they start to say, oh, there's a lot of stuff here I can patch. Where opticalCON duo is typically found on equipment, not all the time, but typically found on equipment, opticalCON quad is typically found on for patch solutions. Again, to get from point A to point B to move a lot of fibers around. And along that same realm, we also recently introduced, and this was earlier this year, opticalCON MTP. Now the MTP is a special connector. This way LC is a connector, or ST is a connector. The MTP is also a connector style. It's a very, very small form factor that allows 12 fibers to fit in that same D-size housing. So this looks very much like the quad. We color it orange to differentiate it from the quad. But now with this you can transmit 12 fibers of information. And this little picture here is very small, but you see how this is typically done, that there's this MTP connector on the chassis connector side, and then a breakout cable or a breakout cassette or some other sort of breakout box which gets you to a whole bunch of LCs or STs or SCs, whatever you need, that will get you to your equipment. So we're selling a lot of these for companies that do big mixed AV events where they're sending a lot of different video signals to a lot of, and audio signals to a lot of different places. Big corporate events, like a General Motors rollout or something like that, and big staged festivals where there's a lot of, as I say here, heterogeneous data streams. That's too large a word just to say a lot of data going to a lot of different places. All right, so these are the three parts of opticalCON. There's the duo for equipment connections, basically, the quad for point-to-point patching, and this MTP for even more point-to-point patching.
I did get a couple questions in if we could take just a minute.
Yes, please.
So quad connectors are not SMPTE 311 compatible?
Great. This is a great question. It's the SMPTE 311 connector. Let me go way back here to the dual connector. When SMPTE was deciding which connector to use to connect to the cameras, they chose a connector from LEMO, which has since sort of been renamed or is referred to as the SMPTE 311 connector. It's also 2-fiber, 4-copper, but it's a very specific form factor. Now, this is not an exclusive connector for LEMO. They had to license it out once it became a standard. So it's also made by Canary and Kings and another couple companies. The SMPTE 311 connector from LEMO is compatible with this only in the sense that it's carrying the same sort of data. So there are lots of cables that are manufactured that have got the SMPTE connector on one side. Just imagine over here a SMPTE connector, and that would connect to a camera. And then on the other side, there's opticalCON, which is used for patching from that point forward to patch around the studio. And then typically there's another opticalCON to SMPTE, to LEMO or SMPTE patch to get to the camera's CCU, because the CCU also will typically use a LEMO connector. So to answer this question more specifically, the LEMO connector / SMPTE connector is different from the opticalCON connector, but they can carry the same data. They are both widely used, and there are lots of installs where the camera and the CCU connections are LEMO, and everything in between there is opticalCON. There are some advantages to the SMPTE connector which opticalCON does not have. Ours is IP65. That means that it can get rained on hard and sprayed with water hard, but it cannot be submerged. The LEMO or the SMPTE connector is IP67. That connector can actually be submerged in water. And so for this reason, for a couple other reasons, if it's an outdoor broadcast environment, use that LEMO / SMPTE connector. If it's an indoor environment where you don't worry about those things, with very few exceptions, opticalCON is perfectly fine to use.
Great. So they're saying you can mix LEMO and opticalCON, and somebody said that's fabulous. So this next question I got is MTP and MCO the same?
And MPO the same? This is a great question. MPO. All right, so I love this question, but this is going to get really nerdy. The MPO connector was created, and then a company called U.S. which is sort of a consortium of Corning and a couple other companies, took it and they made a couple very small improvements. They would call them improvements, and they branded it as MTP. Now here's the tricky thing. So MPO and MTP are the same. However, the idea of branding it as MTP meant that now Corning, or this company U.S. which is this consortium, goes to all these different contractors, like military contractors, and says, please specify MTP on your print, in your design criteria. So what this means is, even though the MTP is very similar, is essentially the same as the MPO, if this company can get the contractors to specify MTP, then they are the single source for MTP. Now this is really causing a lot of anger with all of the other MPO companies which are not U.S. because they say, hey, it's the same thing. It's an interesting marketing move. But now, having said this, let me get even more complicated. If you read this on our slide, the rear of the opticalCON JAS connector accepts only an MTP Elite male connector. So, okay, yes, MPO and MTP are the same thing. However, MTP is made to specific tolerances which we know. And the MTP Elite male connector is also made to a specific tolerance which we know. This is really important because you can imagine that this connection point, when you connect these two MTPs together, you've got to align these 12 fibers in this tiny little space. The space has got to be exactly perfect. We know that the MTP Elite male connector will always work. We don't know if the other MPO connectors will necessarily always work, so that's why we specified that it must be MTP Elite male. Similarly, on our cable, we called opticalCON MTP rather than opticalCON MPO because we know the specifications of the MTP. We know that there's not going to be slop in there. We know it's going to work. So, yes, MTP is the same as MPO, and that gives you some history there.
Great. I think we've come to the end of the questions.
Good. Well, you all are earning your CTS credit today, that's for sure.
For sure.
But by the way, this slide again is kind of a magnification of some of the different ways you can break out the MTP connector. So on the top you see MTP breaking out to a bunch of LCs. On the bottom you see what's probably a superior solution, which is an MTP to MTP cable, which goes in this cassette. And then on the cassette you can have 12 LCs or STs or SCs, whatever you need to have. Like I said, whatever you use, use an MTP Elite male connector on the rear of the opticalCON chassis connector. That's the one that we know works.
So another follow-up question, what
Yes.
should somebody say to their ADC people that are using MPOs?
Well, you can say that unfortunately Neutrik is specifying and requiring the MTP Elite male connector. But for the ADC devices like this box, we don't care. It can be anything. It's fine.
Great. Thank you.
Yep. It's it has caused some consternation that we branded our product MTP rather than branding it MPO, and it's a tricky situation. So we have some other cables. Now we're getting a little bit more esoteric. We have some split cable assemblies, so you can have the split housing here, and you can have 2 or 3 duos or quads. This is often used for various different interconnection options. This was our 12-fiber solution until we came up with MTP, and it does fairly well. Okay. This power split cabling is also, this is a very interesting cable to know. Take a look at the cable construction. These dots on the outside are copper wires, and so then all these wires get twisted up and they become equivalent to a large copper wire, and then those are protecting these little blue dots here are the fibers in here. They're protecting the fibers. So with this particular cable, you can break out and you can get 16 amps of power through a PowerCon, and you can get 2, 4, 6, or 8 fibers here as well. So this is it's a very expensive cable. It's typically thousands of dollars. But it's a cool solution for companies that want to run one cable out to a remote box, connect everything up, power it up, get your data going, and go forward. This is our power split cabling. The cable is a Neutrik proprietary design. Of course, opticalCON and PowerCon are Neutrik proprietary designs as well. It's interesting cable for you to know. All right. Only Neutrik tested and approved rugged cable can be used in opticalCON. Here's just some different examples of what this rugged cable looks like. This is so important. Remember, again, the strain relief. We have these crimp-on strain relief parts. The only way that you can strain relief to this type of cable is to use a metal crimp part, a circular part. And so we have to test that cable very specifically against our strain relief to make sure that the cable will hold, that the pull force is good enough, and there won't be any slippage. So for this reason, we sell opticalCON as a system. It's got to be, it has to stay rugged. We only allow the cable connectors to be sold along with the cable pre-terminated. Some of you in the past may have said, hey, how can I purchase opticalCON cable connectors? And the most basic answer is don't. Go to BTX and have them make your assemblies, because you need to use exactly the right cable. This is a reason why some other connectors can be a little bit more risky, because they're not necessarily paired directly with a particular cable. And so if the cable is not made well, or if for whatever reason it's out of tolerance, the connector will slip off and you'll have a failure. That's something that we really try to avoid at Neutrik by having this program of using a very, very small number of cables, which we very, very carefully test and approve from some very, very high quality vendors. Okay, this talks about the cable options. We have what we call our standard cabling, our extreme cabling, which is a double jacketed cable, and an armored cable, which is a steel jacketed cable. We have various different cable options here. This is a bit tedious of a slide, so I'll kind of move past it. We have couplers for opticalCON. The nature of opticalCON is that if you do want to couple cables together, you do need to use a coupler. Those of you who are familiar with SpeakOn are familiar with the fact that we typically use a lot of couplers in our products. And again, notice the color coding. You see the black, the blue, and the green? That blue indicates single mode. That black indicates multimode. That orange indicates that this is an MTP, black multimode coupler. So these color codes make sense. This part I also want to talk about, this little protection device, SCNO-FTW-A. It's a metal protection device that you can plug into the chassis connector to achieve an IP65 rating when you have not plugged in the cable. And then when you do plug in the cable, you see that the cap can then plug into the end of the cable here, or the dust protection cap. So now you're IP65 rated at the cable to chassis connection, and you're also IP65 rated for your dust cap, so your dust cap doesn't get contamination when it's not attached. This is a nice little device, and at this point I think I'm into pure Neutrik selling. It's a nice device for you to be aware of if you're doing things that are outdoors. Indoors you don't need it, but outdoors it can be very nice to have. We have lots of rack panels, breakout boxes. Companies like BTX will make their own breakout boxes as well. Good things for you to know about. I'll skip past word a little bit. I don't want to be sure we don't run out of time. We've got splitter solutions, different mounting solutions like this in case you ever have a situation where you need to mount something but you don't have a rack panel available. We have some things for you. Again, we talked about this color coding. We have color coding rings that match color coding gaskets. We have these flip-top covers, which are fantastic, by the way. If any of you are Neutrik users who use D-size connectors and you don't know SCDX, take a look at, make a note. Take a look at SCDX. It's a beautiful little flip-top cover. It's inexpensive, but it provides nice little protection for any kind of outdoor use. We sell a lot of these to ballparks, like baseball parks where they have to water the field. There's a lot of fertilizer. There's a lot of possible corrosion of the connectors. Put these on there, flip them down when the connector's not in use, and it protects against a lot of that kind of corrosion. Again, I hate these gaskets because you should really only use blue or black for single mode or multi-mode, but then we offer these other color coding options. So I know I'm being a little inconsistent in how I talk about this, but the color coding options are nice. We have some pulling socks. Well, we don't sell too many of these, but this is if you really need to pull opticalCON out in the field and you want to provide some protection, it's a product that can do that for you. We have transceiver adapters, so you see that there's kind of an LC on each side. These are designed to connect to the chassis connector on one side, and with that transceiver, remember looking at the transceiver, on the other side, so you can directly connect up a chassis connector to a transceiver. Before you purchase this product, talk with BTX or talk with me about it. It's one solution. This is really for OEM integrators. Don't use it if you're not building OEM equipment. And if you are building OEM equipment, like I say, talk with us before you use it. I'd say specifically talk with me before you use it. I can talk you through some of the issues with that connector. And then field assembly. All right. So now we get into, can I terminate opticalCON on my own? Yes, you can. We have a kit that lets you do it. But let's talk about the differences. If you want to do field assembly, we have a kit that's based on Corning Unicam connectors or based upon fusion splicing. This could be a little controversial, but there are three basic ways in which fiber optic connectors are typically terminated. One is an epoxy and polish process. This is the military mil-spec process. It's what BTX does. It's what everyone else does who terminate opticalCON. It is the best way to go. You apply some glue, you stick ferrule on, then you have a lot of polishing, a lot of testing, repolishing, and it provides the strongest connection with the lowest attenuation. We always want low attenuation. These Corning Unicams, by contrast, use an index gel match, so there's sort of like some glue inside the connector, and you stick the connector on, and the glue sort of hardens, and you provide a pretty good connection. And fusion splicing also provides a pretty good connection, but these connections are not as good as the epoxy and polish process. They don't spec as well, and they're not as strong. So if you want to do field assembly, you can do it with us, but it's not going to be as good. It's going to cost you a lot of money and tools. It's going to cost you a tremendous amount of time, and we're going to force you to take our training class because we want to be sure that if you're going to do it, you're going to do it right. We have a training class about once a year in the U.S. Like I said, it's something we typically really kind of discourage. A lot of users say, well, what do I do if my opticalCON cables fail in the field? Well, since we have that LC compatibility, right? You can plug LC connectors into the front of an opticalCON duo chassis connector. We say, get an inexpensive little kit like the Corning Unicam kit or the Belden Brilliance kit, and bring some LCs with you. And then if you have to, snip that cable end off, terminate it with some LCs, plug those into an opticalCON duo chassis connector, and you're good to go. It's going to be faster and it's going to be less expensive than trying to do it on your own. And then, when you have some time, send your cable back to BTX for repair. opticalCON failures are very low. And I have to say I'm astonished at how many big tours go out, the biggest tours, and they don't even bring a spare reel. I mean, it's unbelievable to me. They just assume everything's going to work, and it does work. I'm a more paranoid person. I like to have lots of spares in my life. And if it were me doing something really big and expensive like that, yes, I would have a spare that I could be sure I could get to the show within a few hours. But it's astonishing how few companies do bring spares or repair equipment or like save and test equipment of any type. Any questions about field assembly? It's kind of an interesting rat hole to go down if you want to go down there.
I haven't gotten any questions about field assembly.
Okay, good. I'm going to move on then before it's too late. And then we have this product. This is a great product range. We love it. We never sell enough of it, but we really believe in it. Power monitors. So, with fiber optics, the issue is always that, hey, it worked yesterday. It's working this morning. Is it going to work this evening? is my fiber getting dirty? Is it getting dirty to the point that I'm going to start to have problems? You know, am I close to a point where I need to clean? And to be honest, like I have said throughout this presentation, most of our users never ever deal with this. They just, you know, they use the products, they don't concern themselves. But this is a great product. It will monitor every fiber strand for the power in dBm. Now, dBm is the standard by which we measure optical power, dBm. So it measures every fiber strand. You can set programmable thresholds and alarms on this thing. So if any fiber strand falls below a threshold of power that you define, the box will beep and flash and let you know that it's time to do some cleaning or have some sort of problem. These are wonderful boxes. They're used a lot for, you know, really mission-critical applications like the trucks that go out and do the Super Bowl. You know, they'll use a lot of these to be sure that the fiber power is truly working well. They're inexpensive for what they are, but they're still going to be $1,000 or a couple $1,000s per box typically. And they're like one of these nice-to-have items. So for you system integrators out there, you know that you've specified this beautiful system, and then your clients come back and say cut costs, and it's always the nice-to-have stuff that you know gets hacked out of the budget. So I understand that, but it's a product for you to know about. It works wonderfully. It's just sort of a leave it in there and forget kind of device, and it can help people understand, you know, what's happening with their cabling, how they need to clean, what's happening to their attenuation over time. And as all of you know that are on this call, you know, the worst case is the border case. When something completely fails, it's easy to diagnose. But when you're beginning to get weird behavior, that's what's really tough to trace down. And if that is attributable to the fiber just falling, you know, right into the margins of good enough power, that's where these boxes can be very helpful. Okay, big question: when is ruggedization necessary? Again, don't spend money on ruggedization unless you need to do it. If you can get away with the inexpensive fiber optics, use those. I always say, and I'm not joking, we want you to buy the least amount of opticalCON that you need to buy. We don't want you to buy any more than is absolutely necessary. But when you've got a patch point, okay, you're patching from point A to point B. We want you to have a rugged chassis connector on each side. We want you to have opticalCON on both sides there so that that patch point is going to stay successful. Other than that, you know, behind the rack, use that cheap cabling. All right, so let's take a look at some of these different AV applications, and now we'll talk about this a little bit. Television broadcasting is where fiber in AV first really became ubiquitous. It's very widely used. Many HD broadcast cameras and CCUs, camera control units, come equipped with either the SMPTE connector developed by LEMO or the opticalCON connector. So we talked about this connector before. This is more often than not, it's the SMPTE connector which you will find on a camera. SMPTE cabling as opposed to the SMPTE connector, so this is a different standard. SMPTE cabling always has 2 single-mode fibers, that's a send and receive fiber, 2 copper wires for power, and 2 copper wires which are used for sense and status operations. So is the camera on? Is it working? Does it need to throw a message? So this is, again, I should have backed up. The point of this part of the presentation is to talk about where is fiber used. And so we'll just look at a bunch of different places where it's used. It's also in TV broadcasting. A lot of people don't like that SMPTE cabling because it's really heavy. It's got all that copper in there plus all that fiber. So there are companies, and Telecast was the leader in designing this, which broke off the power from the fiber. So this allowed people to use either low voltage camera cable, which has just 2 coppers, or in many cases completely different fiber and copper, which reduces weight and reduces cost. So another application for fiber. Fiber is often used to convert cameras which have BNCs on them to use fiber for higher quality, because again, remember, there's no electrical interference, and also for longer runs, because remember, what's the maximum distance for copper? Best case, 100 meters. Best case. And here often, a lot of people would never run a camera 100 meters. I also would not run a camera 100 meters on a BNC or on copper. TV studio routing, this is also something we touched on earlier, which is that you've got all these patch panels. You're patching all this gear to different places, cameras to different CCUs, signals in different places. That's typically done with fiber and very often done with opticalCON for that patching. And opticalCON is wonderful for patching because it's got these built-in shutters. Now, one thing I've always hesitated with this presentation is I could show you some pictures of other connectors, for instance, from LEMO or from Stratos. And you'll see with these other connectors, you typically have got screw-on caps and other different sorts of mechanical things that you have to do in order to prohibit dirt and dust from entering that connector. With opticalCON, you don't have to do any of that because, again, the shutters are operating automatically. You don't have to screw anything on. You're automatically protected on both the chassis connector side and on the cable side. This is a new product we have, OpticCam Switch. I won't talk about this too much here, but if you have a TV studio or if you work in the TV studio area and you're used to using simply patch base, you think, boy, it'd be really cool to automate my patch base so I could send my cameras directly to my CCUs, by the touch of a button over a network. Feel free to contact Kim and we can speak about this more. We'd be happy to talk about it with you. It's a new product for us. It's doing very well and it's powerful. It's very much outside the realm of thinking about Neutrik as a connector company. This I will skip. We have these reference projects for broadcasting, but they're kind of ridiculous because at this point, every TV studio in the United States, or every network, every studio is a big opticalCON user. So we will bypass this slide. Okay. Some of this equipment is interesting here, this mobile broadcasting equipment. This is a single box. This is from a company called Nevion out of Finland, but some other companies make this stuff as well. It's got this one opticalCON connection into it, and you see it's got all of these HDSDI signals, Ethernet ports, audio ports. So this is used for, for these people here in the commentators. They can see all of their different monitors. They can be talking with their producers. They can be, their on-air microphone signals can all be transmitted. All this bidirectional communication, and it all happens over one box. So they just bring out this one box, they connect it up, and they're good to go. This broadcasting equipment is very powerful, and there are more and more devices like this from companies like Multidyne, Studio Technologies, and other ones that really multiplex a lot of, again, different data types and different signal types onto fiber in order to transmit. And again, this mobile broadcasting area is a big area for us. All right, so that kind of covers the TV side of it. Are there any questions about the TV side before we look at some other options?
I don't have any other questions that have come in.
Gotcha.
Oh, wait. Let's say, can opticalCON handle normalization without a looping plug?
Let me handle that question offline.
Okay.
How's that?
That's fine.
Sorry to blow you off, but yeah, that's a little bit longer.
Okay, great. All
right, so let's talk about live AV. And again, I don't know the the composition of the audience here today, but I hope that I'll cover your specific area by the time we get to these different application slides. So the easiest probably to understand concept for live AV is that a lot of audio and video snakes have moved from that big, heavy multi-core copper stuff, very, very heavy, very expensive, to first Cat5 and now fiber snakes as well. Cat5 snakes are perfectly fine. Nothing wrong with a Cat5 snake. But remember, there's the 100-meter limitation, right? So when you need to go further, a fiber snake can work well. And companies with fiber snakes include Aphex, Fiberplex, Opticore, PV, Proco, Telecast, Whirlwind. There are a lot of people playing in this space. But now's a case where I want to mention a lot of these names of these companies so that you can learn some new names if you know these. Connecting mixers to stage boxes. So in this case, this is sort of like a digital snake application, but you've got companies like Studer, SSL, just recently released a console that does the same thing. We see this from, I think, Allen and Heath, but there's some other console manufacturers as well, which basically have their own ecosystem. So you've got a fiber connection between a stage box and the console as well. As I say here, running fiber, and it's true both here and also for the digital snakes. When you run fiber from the front of house to the preamplifiers, you get better signal-to-noise ratio. You've got a lot less cabling bolt to deal with. You've got a faster setup and teardown. And again, you're not worrying about EMI interference or RF interference anywhere in that transition from the stage to the front of house position. opticalCON is used tremendously through Las Vegas, Broadway, concert tours, large houses of worship. It's just when you've got these distances to cover the Cat5 doesn't cover, or when you need a ruggedization which you cannot get from copper. Fiber is a good solution. And again, these cables are so rugged. If you haven't seen them, have your BTX rep come out and see you and play around with these cables. Like I said, it's the stuff that gets blown up in Afghanistan. It's very, very rugged. Very rugged. Okay. Distributing audio signals. So this is sort of a bit of a catch-all, but we now have MADI. We've been talking about MADI a little bit in this presentation, and we've got other ways that we transmit audio around facilities. It can be music studio facilities. It can be campuses, all sorts of different ways. And this is sort of an interesting field with, how do you distribute these signals around? And this is the way to do it. Again, using fiber. And again, I mentioned some of the companies here that are involved. AMS Neve, which is an old classic name in analog audio, is doing these networks now, as is Apex, Telrec, Fairlight, Focusrite, Klotz. Even companies like Millennium Media are putting transmission devices on their and remote control devices on their preamps. So this idea of distributing digital audio is always increasing. Let me move down the next slide here. 1 second. I include this slide about Roland because for those of you who know Roland, you know that it's very much a mid-tier company or lower tier in terms of price. I mean, it's not a Neve, it's not an SSL, but even Roland is now using opticalCON as an option for their snake solutions. And so this is just sort of a point that, what started as a very upmarket solution for $250,000 consoles is now, continuing to come more and more down market into, the medium churches and such. Loudspeakers are, again, as we just talk about various different applications, loudspeakers and amplifiers are being networked, intelligent devices that can speak with one another and that can speak back to a central control area where one person doesn't need to go out and look at all the amps to see what's going on with those amps or to program the DSP, whatever. These amp and loudspeaker networks are also cases where both Cat5 and fiber can be used as well. And remember, of course, anywhere Cat5 is used, you can add a fiber extender to accomplish the same thing using fiber. Some other examples here. DMX512 lighting applications. If it's moving lights and even moving trusses, fiber extenders are taking care of length limitations. There are lots of cases where you really do need to move beyond 100 meters for these big lighting setups, and using fiber extenders along with these DMX applications can be very successful. We don't need to look at that. And AV switches. So I think the idea is, for a lot of us who are of my generation, we had audio and it was separate from intercom and it was separate from the video camera and it was separate from projection. But now all of this stuff can be combined and multiplexed on one network. And companies like Lightware, ThinkLogical, TMB, XL&T, I think really probably in the U.S., these first three are really worth paying attention to. They're building very interesting devices that use fiber to bring in all sorts of signals and switch them all over, and again with essentially zero distance limitations, and at very, very high speeds. 1 gigabit per second. These speeds will only continue to increase. And this is a part of the same thing, this mixed signal distribution. If you don't know a company called Riedel is a company out of Germany. It's worth looking into Riedel, even if you're not specifically in the concert space. They're sort of taking this to the ultimate extreme, which is that they will run your entire show off of their one box. So everything, every signal possible comes in this box, gets sent down fiber to another box and gets distributed. Riedel had a little bit of a problem in the U.S. in the beginning because people said, boy, if that one box goes down, my whole show goes down. It's not just the lighting, it's not just the image magnification or the audio. Everything will go down at once. And Riedel has addressed that with tremendous redundancy built in their boxes and other schemes, and now they're really making progress here. But Riedel's a cool company to check out because, like I said, they're sort of taking this to the ultimate extreme in the live AV space, which is, hey, again, it's all signal, it's all digital signal. Let's route it all through one particular device. And then I guess we should talk about protocols. there's been CobraNet, there's been Ether Sound, but AVB, which for many years was kind of a joke and a lot of us thought was never going to happen, has really taken off. And so this audio-video bridging, which involves specific hardware implementations on the chips to really work at fixed low latency over network, is going to be a big player for all of us. Where we used to switch data and think like, well, the latency's okay, it's not really predictable, but it's good enough. It's not as low as we would like it, but it's good enough. AVB has solved a lot of these problems, and we're going to see a lot of AVB equipment coming out, and I think for all of us who work with live audio especially, AVB, everybody who works with campus type of applications or distributing signal, we're all going to have to learn about AVB. That certainly includes me as well. And then here's this is just an interesting diagram to me. We don't have a tremendous amount of time, but I'll see if I can show this here. Sorry, my computer's being a little nasty. So this is an actual concert application, and the interesting thing here is we used to run a tremendous amount of cabling to get, for instance, to the image magnification here. A lot of cabling to get to the lighting. Here's the amp racks and the stage boxes. We can really now simplify the cabling because we've got devices that can provide so much bandwidth. So again, fiber optics is not good for the Neutrik overall copper business, or for anybody's overall copper business, because it replaces so much copper. So many copper cables can be replaced by these very high bandwidth fiber cables. And again, because it's light, there's absolutely no degradation of the signal as it moves forward. So don't blame fiber optics when you go to a live concert and the sound is so bad.
Mm-hmm.
All right, let's take a look at some of these high-def video applications. High-def video is also really, really driving fiber. With the use of fiber optic converters and extenders, copper's distance limitations are effectively eliminated. So we often see a lot of fiber that's running to small little boxes like this box here from Technological, which is converting fiber to copper. So it's copper next to the device, in this case maybe next to the Christie projector, and then the fiber to make the run forward. Video displays, these very big video displays, these jumbotrons tend to use this as well. Let's see here. Find some other slides for you. Remote control cameras, another example. And then for those of you who do system integration, opticalCON and fiber is used a lot for inter and intra-building applications. There's a lot of fiber signal transport. Any of you in the system integration space know AMX and BiAmp and Crestron and Everts. And these are all, a lot of opticalCON is used as data is transferred amongst these boxes. Now remember, these boxes typically don't have a rugged connection on them. The idea is you put it in a rack, you run an inexpensive little patch cable between that and the rear of an opticalCON chassis connector, and then you run opticalCON cabling out to your destination devices. You can always extend a network using a fiber optic device, and this is a good example here. Here's a very inexpensive device that has an HDMI input and optical output. Then you use a cheap little cable like this to hit opticalCON, and then you use opticalCON cabling to get to your final destination. Again, more conversion. This is not exactly our conclusion because we're going to have a test. Isn't that fun? So let's take our test together. I'm just going to put it up on the screen here, and let me know. By the way, this is part of the CTS thing, but this is kind of a fun way to be sure that we've kind of locked in our knowledge. Kim, can you let me know, looking at this quiz, is this readable?
It is. I can see it.
All right. So for those of you taking the quiz, I'm so sorry that I can't judge you in person. But why don't you take some time and take a piece of scratch paper or something and answer these 10 questions. Let's do this until it shouldn't take that long. Let's do it until 12:55. And meantime, let me take any questions from anybody as well. This would be a good time to take those questions.
I know you did touch on this, Fred, about the price of equipment when going from multi-mode to single mode, that they're sort of evening out a bit, but yeah. Somebody said this is a real sticking point when trying to sell single mode over multi-mode because of the price of that. Do you want to expand on that any?
Yes, it's a great question. You know, if your customer only needs multimode, then by all means sell them the less expensive solution, in my opinion. But at the same time, if your customer needs single mode, he or she needs it because the distance limitation is farther than multimode can handle. So that part should be an easy sell, which is, look, you can't put in multimode because you've got to travel farther than multimode can travel. You have no option. You have to choose single mode. But I don't really see. I don't see a need to oversell a customer. I don't see a need to move a customer onto single mode if multimode will take care of it.
So then let's move it back one step. What about going from copper-based solutions to fiber because of equipment costs?
Right. Well, you know, a lot of again, this is a reason why I really try to make the point that we've got these distance limitations with copper. Remember, you know, BTX, Neutrik, we are big copper providers. We love copper. You don't need to sell more opticalCON or more fiber optics than the user needs. If the user has RF interference issues, worries about lightning strikes or EMI, whatever, fiber is a good solution. If the customer has distance limitations which cannot be overcome with copper or which require a whole bunch of copper repeaters which wind up being expensive and cumbersome, well, then fiber is a better solution. If the customer has a whole lot of patch points which can be, patch cables, points of failure which can be reduced by multiplexing and going to fiber and simplifying the solution, well, then those are other good sells as well. So I think, you know, the most important thing is understand the equipment and what the equipment can do, and you know what that equipment can only provide using fiber. My best example probably this is Crestron. For those of you who use Crestron or Extron or AMX equipment, I'm really all three of these companies. There are things that their equipment will do which really require fiber, and in that case, you know, use fiber. But I'm not. I guess, you know, one of my goals here is not to get you to think like I've got to now specify fiber all the time. I want you to know about fiber, and I want your customers to know about it, and I want you to make the right intelligent decisions based upon the customer needs.
Great advice. I think everybody's
easy for me to say. I'm not, I'm not incentivized on sales. So.
Everybody is still has a couple more minutes. I haven't gotten any other questions in. There are some, like, that you talked about taking offline, and there are some follow-up questions to that, to normalization. So same person. So we're not blowing you off. We'll just take it offline.
Right. Sounds good. Sounds good. And I'll tell you what, when you are done, why don't you, send a question into Kim that just says you're done, and she'll know, and we can be good to go.
Okay, I'm starting to get finish, done, 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 finish, done, finish, finish, done.
Okay, well, we'll go another minute or two here.
Okay. Are there any combination boxes that can combine multiple camera feeds with SMPTE 311 cables?
Multiple camera feeds. I would ask this question of telecast. Okay. It's a good question. I don't have an answer, but I think that telecast will probably provide some of your best answers for that. That's a very, very high quality company that continues to invent a lot of this technology.
Absolutely. Is there such a thing as an MPO MTP adapter?
Well, they're the same thing, so no, they are the same. But again, in opticalCON world, specifically in our world, just stick with the MTP Elite Mail. Stick with it, and you'll be guaranteed to have things work. We always have to worry when we work with this stuff. It's also true with our EtherCON products. There's stuff out there that's just not to good tolerance. I mean, it in the XLR and quarter-inch world as well. And I don't want to demean any other companies, but we've had success by just sticking with U.S Connect's MTP Elite line, and we're not alone in that. A lot of other companies have also made that decision that the tolerances are they're just always perfect.
Does anyone make a combination multi-mode and single mode cable?
It's not possible. Good question. You cannot have both multi-mode and single mode because one is 50 micron and bounces that light up and down. Another one is single mode, which is 9 micron and shoots the light straight through. But there are transceivers which can operate on either level. I want to be respectful of everybody's time, so let me now move into the quiz, and let's answer some of these questions. Oh, I wish we could all do this together, but I guess we can't. Circle the fiber optic technology that can run the longest distance. The answer is single mode. Remember, single mode can run 10 times the distance of multimode. Which fiber optic technology is more expensive? Question number 2, single mode. Why is it more expensive? Question number 3. It's more expensive because it requires expensive laser-based transceivers rather than the less expensive transceivers for multimode. So the question here is the answer here really comes down to the transceivers. So why don't you let Kim know so far who's got 100%? If you've got 100, just write 100 and let her know. You can bombard her with that. Number 4, we'll move forward. Which technology has a higher tensile or pull strength? Remember, fiber optic cabling can be pulled much harder than copper cable. Question number 5. For running 1 or 2 channels of digital audio 50 feet, which is the more economical solution? The answer here is copper. So you're 50 feet, you're under that 100-meter limitation. You're only running a couple channels of audio, so you don't have to multiplex some tremendous amount of data. So, do it over copper. No need to use fiber in this case. This kind of gets back to the point that we talked about. Number 6. Neutrik opticalCON chassis connectors come in 3 different variations. What are those? It's 2, B2, the duo, C4, the quad, and E12, which is the MTP. And I guess I kind of skipped over that MTP, the fact that MTP is 12 fibers in one strand, and that's number 7. opticalCON MTP has 12 fiber strands in one connector. Okay, number 8. What's the maximum effective length of twisted pair cabling? 100 meters. Now, once again, email Kim if you're at 100. And if you're not 100, why don't you email how many you missed, like -1, -2, -3, something like that. And then, Kim, you can let us know where we stand.
Got a lot of hundreds. Got a lot of smart people and a good teacher. Oh,
okay. All right. Good.
We have somebody who is asking the answer for question number 7. That was the 12 strands.
I'm sorry. That's 12 strands, right?
Yeah.
And so a couple more. We really skipped over number 9. So you might only know this if you already knew it before coming in. But SMPTE 311 cabling is 2 fiber strands and 4 copper strands. Again, 2 for power, 2 for sense operations. That's number C. Letter C. And 10, your 3 providers of fiber optic equipment. Again, this could be Crestron, Extron, AMX, Fiberplex, Telecast, Telemetrics, Think Logical, a ton of different providers. So once again, if you've got 100, why don't you email into Kim and say 100, and then we'll give you a virtual pat on the back. How do we do there? Kim?
We've got a few hundreds, but we've got a few people who just missed it, 1 or 2.
I got you. And by the way, it's very rare to get 100, I have to say. So I was surprised that many people had done well when we got to question 7. I could tell you the statistics at BTX, but I'll bet that this group here has done better than the BTX's first training. It's we're all learning. So let me just quickly wrap up by saying, first of all, we love our Neutrik clients. Thank you for being Neutrik clients. Second, of course, thank you to BTX for setting this up. It's wonderful to be able to talk to so many people at one time. Third, I thank you, each individual attendee, for your patience and your attendance. I know it can get dry, but I know now that you did learn some things through this. I think it's great. We're all on this fiber journey together. I'm certainly on it. You're on it. BTX is on it. We're all learning. Technologies keep changing. And the great thing about BTX and Neutrik is we're here to help. So if you have any of these questions, we're going to take some very serious questions here later this afternoon. Please let us know. Be in communication with us. Talk to us at the trade shows. Send me emails. Kim can always give you my email address. My job is to help you succeed with your clients. And so if you don't let me help you, I'm out of a job.
I don't think you're going to be out of a job anytime too soon, Fred.
All right, so and I also have to say I'm very proud of myself to wrap up here a minute early. So, thank you very much to anybody. I'll stay on the line for another couple of minutes if there are more questions. And otherwise, again, I'm incredibly appreciative of your time. Be sure if you need a CTS credit that you let Kim know that you do. And Kim can then forward me those names. I'll create the certificates, send them to BTX, and then Kim can send those out to you so that you'll get those credits and you'll have your nice certificate. So once again, thank you everybody very much. Thank you.
And Fred, and I agree with Fred. I thank everybody for sticking it out. It was an awesome 2 hours. I actually learned more than I ever thought I'd ever know about fiber. So I'm going to go look and ask, okay, lots of questions about CTS. I think you covered all of that. There was, what will cause a shutter to fail or to not work?
Oh, okay, this is a good question. On the cable end, I should make the point that the front part of the shell, which has got the shutters, is user replaceable. So if you have a problem, you can pull it off and remove it. On the chassis side, if you have a failure, you have to replace the chassis connector. Now, we have a theory. First of all, I have to say that I personally have not heard about a shutter failure for about the last 6 or 9 months. Our theory is that typically a chassis failure is caused by some engineer who says, that's an interesting looking connector. They take out their screwdriver, their pen, and they get in there, they kind of wiggle some things around, and they cause some damage. This is, I know that this almost sounds like an insult to our users for me to say this, but I know that this is the typical cause of a failure, is this sort of thing. Other causes of failures that we've seen have been contamination by really big, like a rock or something that just happens to get in that shutter. Yeah, I should say pebble, but for the size of the connector, it seems like a rock. Some sort of big contamination like that will get in there. And then, honestly, there have been some breakages which we have never been able to understand. But the breakages, I will say, are very rare. Our COCAs, our certified opticalCON cable assemblers like BTX, now are typically the front line for this. A couple of years ago, I was more the front line, and I would really hear these things. But other than a couple of very isolated cases, and those have both really involved either dust or abuse, I have not heard of any other failures. It's a fairly simple mechanism. It's a spring-based mechanism, so there's not really a lot that can break there unless someone gets in there and starts fiddling around with it. I should also point out, by the way, that the cleaning of the front shell, if you did get some contamination on that front shell on the cable connector, you just take that thing off and rinse it underwater. Just put a good strong stream of water in there, rinse it off, let it dry, and assemble it back on, and you're good to go. So it's all of opticalCON is designed for easy cleaning and easy repair that way.
Great. Somebody made the comment, stagehands cause failures.
Yeah, right. Yeah, I always talk about opticalCON as being roadie-proof. It's a significant, any new design that Neutrik makes, no matter what it is, we always got to think about those roadies and say, is this going to withstand those people?
That's right. So can we talk about brands that are okayed by Neutrik, like Belden, maybe OCC, Gepco? Gepco.
Right. Yes, there are very few of us on this call, so I'll say a couple things. First of all, OCC, Optical Cable Corporation out of Virginia, is by far the most common provider of cabling in the U.S. market. And the reason for this is that for Belden, they have their operation in Indiana, but they also have an operation in Europe, and they have the same part numbers, but they construct the cable differently, and Belden will say this as well. So for Belden, we have only approved the Belden cable that comes out of the Netherlands. It's great for Europe, but it's a tremendous hassle for people to get in the U.S. and for companies like BTX to get in the U.S. And so therefore they typically just use OCC stuff. So OCC is dominant. There are some opticalCON cable assemblers like Gepco who are also assemblers who also make their own cable, and so a couple Gepco cables are approved. I think only two. One of them being their they might both be variations of their SMPTE cable, but I know their SMPTE cable is approved. And there are another couple approvals here and there. There are some other private label approved cables that you may think that it's from one country or another, but it's really just a pad printing that's on top of an OCC cable. I have to say, and if there's anyone from Belden on this call, I'm sure they'll hear about it after the call. But I have to say that I think OCC in the U.S. makes a great product, which is widely available and is a really great solution. Their Ultra Fox cabling is a terrific product.
Great, excellent. Okay, we've got people are slowly dropping off. If anybody has any last questions for Fred, now's the time. Or like Fred said, you know what, I'm just going to take back control so people can just see contact information. I'm going to make myself the presenter, I'm sure. And I'm going to show my screen so everybody should see the phone number. sales@btx.com. That's for any technical questions. For the CTS, you could do kimr@btx.com. Most of you have my my contact information as well from the invite and all the reminders and all the marketing material that you tend to get from me about BTX. So different ways in which to contact us. Okay, let's see. All right. I think. Fred, will you be at NAM?
I will be at NAM. I'd be happy to see anybody there. Love NAM.
All right. I think that's about it. I think we're going to wrap this puppy up. Fred, I can't thank you enough. It was you made what you called dry information quite palatable, and I think it was very, very good. Very, very good.
Thank you.
Thank you, everybody. Have a great day and great weekend. Bye-bye.
Bye.